Hello, everyone. Let's get started. We decided that I'll be moderating today's meeting. Katya, you okay with that, right?
Yes.
Okay. So today, what I thought would be a good, interesting topic to discuss is the different approaches to modeling that we use, and I will try to argue and that science, philosophy, or religion, the real difference between the three approaches to understanding the real universe is in the way how you approach to modeling it. Now, of course, it is true that different words have different meaning for different people, and so we'll have to, at the end of this process, come up with the definitions that satisfy all of us. But I don't think we should be stuck with that in the initial moment. So, and that's why I broke everything into 10 questions, and let's try to go one by one and see if we can make sense and make progress in answering those questions. So the first question seems like completely unrelated to, or maybe it isn't unrelated to the topic of science, philosophy, religion, but the topic is what is rational and what is irrational, right? So we often do things and base things which seems to be on irrational things. And sometimes we do things that seem to be rational, but perhaps people mean different things by those words as well. So I would like to hear what your thoughts are of what is rational and what is irrational, and then I'll try to say what I think it means in the context.
I can easily give you an answer to that question.
Okay, so we have a winner. We have Artyom as all is our oracle for today. He has all the answers. All right, Artyom, go. Oh yeah. Please. And no mathematics jokes about rational and irrational numbers. We all know what they are. Okay, now go ahead.
Well, okay. So rational things, or we call things rational when we can build a logical train of thoughts from some premises to some conclusion, and we call things irrational when we can't do that.
Okay, so can you give me an example of something that is irrational?
Okay, very easy. Recently, my friend posted a message on Facebook. Like, she was stating that she is leaving her job and that this job is very well paid and she's respected and she has a status, but she doesn't want to be there anymore, and she called that irrational. Like, this is irrational move, but I hope it will be better in the end. And
well, look, she might call it irrational, but it could have been a completely rational thing to do, given all of the circumstances that she was in. So I wouldn't count that immediately irrational. Okay, let me just give you maybe some of my.
Yeah, that's the point. That is not irrational, because we can go one step further and say that, for example, maybe you thought that's irrational because you didn't consider your mental health, but mental health is also important, and so by making that decision, you were just caring about your mental health, and that makes your decision completely rational.
Exactly.
So my point is that like, well, in general, there is nothing irrational at all, but sometimes people call things irrational when they can't build that solid line of arguments, like maybe logical line of arguments, when they can't like make that final step.
Right. Well, I'm not very happy with everything being rational, so I'll try to argue there are certain irrational things that people do, scientists do, philosophers do, religious people do, and that's okay. We make assumptions. We make assumptions that something is true, we declare some hypothesis in the theory. We state some axioms. And then we try to use logic, rational logic, to derive something from this. So the first step, making all these assumptions, is common to all three branches, to approaches to modeling the universe. Scientific approach, you make concrete assumptions. In the philosophical approach, you also make some assumptions. You say, this is how I believe the universe works, and in religious views, you also make those assumptions. They're completely irrational, and yet from them, using logic, you can do, as you said, derive theorems, you derive predictions, and those are completely irrational. And I think we do it for specific calculations, like experiments, or as your friend, for more abstract and coarse-grained calculations, where she's trying to decide what would make her being better, right? But she still bases it on some irrational assumptions of what's going to happen next in her job. It's an assumption; she doesn't know for sure, and then from that she tries to derive certain very rational conclusions. So that's my view on what's rational, what's irrational, and I don't think this is, because people very often try to draw a line that if it is scientific, it's rational. Now, if it's religious or philosophical, is irrational. I think this line is incorrect. Whenever you make assumption without justification, you're making an irrational step. There'll be differences that I'll identify later on, but for now, I don't think this is the main difference.
So I have a question. Is it possible for it to be like a combination of rational and irrational? So like, can a decision be like 80% rational, 20% irrational? I know it doesn't make any sense. Okay.
No, absolutely. That's exactly what I'm saying, right? So you can make irrational assumptions completely. And then using those assumptions that may be wrong or may be correct, you don't know, you follow logic and derive some conclusions of what your action should be. This part of deriving conclusions and estimating what the best possible behavior should be is completely rational. But the starting point is always irrational, and that's kind of, I think, the distinction.
So
I think like a good example, would a good example be, so imagine you're a doomsday prepper, and you're doomsday prepping for like the 1 in a million chance that an asteroid hits, or maybe the 1 in 1,000 chance that nuclear war breaks out, and you're doomsday prepping. So that would have to be an example where it's like 50% rational, 50% irrational, because on one chance,
I'm not ready to divide it into 50% rational or 50% irrational.
Or
I think
just arbitrary.
If your prior distribution for the some disaster to happen is high, and you make an assumption that it will probably happen soon, if that's your model of the universe, then everything else you do that by going to the bunker and buying all the food supplies and water. It's completely rational. Assumption may be weird, so and we can talk about later which assumptions may be different, and then what the type of assumptions that philosopher may be able to do, or scientific people may be able to do, and religious people. But that's the difference. But the existence of irrational assumptions, I think, is present everywhere.
So is the cosmic web irrational or rational?
Well, again, the assumption that there is cosmic, you don't need to assume that there is cosmic web. You can assume something that is simpler than that. You can assume there are general relativity. You can assume there are dark matter. You can assume the dark energy, and then from that derive your cosmic web. Then cosmic web is not an assumption. This is a completely rational line of thoughts that led you to this. What was perhaps irrational is the assumption that the world is governed by the laws of general relativity. In fact, we know that it may not be the case at all scales, but that's an assumption you make, right? Now, how irrational it is, again, then you can go and try to do more and more experiments, more and more predictions, and we'll talk about experiments and predictions later. So I just wanted to identify that there is nothing wrong with making irrational assumptions, as long as you know what assumptions are, as long as you explicitly state what they are, and then go there. We do it all the time. When any agent models the universe, that is exactly what it has to do. It has to come up with filters of what information is relevant for me, which is irrelevant. And that's a choice. This is an assumption that this information is relevant. It may turn out to be wrong, and then you have to adjust your filters. You have to adjust your assumptions of what is relevant. Okay, good. So let's move to the second question, which I think may be related. That what are the different assumptions? What is the difference between the assumptions that scientific people, religious people, or philosopher make? So what is the difference? Now Artem knows all the answers, so he will go first. Or no?
Yeah, give me a second.
That's fine. That's fine. I'll start. I'll warm up. So let me start with this. I think the level, because Merrill kind of was getting already into there. He's saying, if I would have assumed the level of assumption, if I would have assumed the existence of cosmic web, okay, then would be very high level assumptions, not very scientific. If you assume the general relativity and dark matter and dark energy, then it is really lower level assumption, and from that you derive your conclusion. So what's different is the level of assumption. What is it that you assume? Can what you assume then later be teared apart and be derived for something more general, something that will enable you to derive not just one phenomena, cosmic web, but also other phenomena, like Newton's laws in certain limits or gravitational laws, right? And so I think that the difference is between levels, and the lower the level, the more you can, the fewer assumptions you need to derive more and more phenomena. So just to tell you what we've managed to do in physics, we managed to write down standard model Lagrangian plus gravity plus dark matter, dark energy. Very, very compact expression. You can write it on a single piece of paper with a small enough font. And that's it. It's ugly as it looks, but that is it. And that tells you, and from that alone, you can derive lots of things, including the cosmic web. So that's a scientific method where your level of assumption is very low. Nobody said that the universe works according to the field theory that we've managed to identify for the standard model. But if we make this assumption, there seems to be a lot that you can derive. So I think the difference is in the level of assumptions. And then the second one, I'll just edit and then I'll ask people to comment. Also, the use of the Occam's razor principle, which is completely related to what I just said. Basically, in the scientific methods, you are trying to come up with the simplest possible construction that allows you to explain as much as possible of the universe around you, to model it. The fewer assumptions you make, the better it is. And that's kind of Occam's razor principle that is being used by scientists. Now, you can say, well, I don't like that. I want to make more general assumptions. I don't believe in Occam's razor principle, and I want to have, instead of one piece of paper which describe everything, I want to have very thick books that describe. You can do that, but that would be less of a scientific approach. Scientific, you try to kind of compress information, use less information to describe more and more phenomena.
Hey, were you talking about Occam's razor when you said
Yes.
razor? Okay.
Yeah, this is razor. It's a principle. Basically, the idea is that if you have two competing theories or models of whatever phenomena, or maybe of the entire universe, the one that has fewer small complexity, fewer parameters to describe it, should be the one that you would want to work with. Now, this is a nice principle. It's ill-defined because complexity is something that has to be defined with special care, but at least this is a guiding principle. In fact, this approach with the fewer parameters was not the main approach that was taken in the 20th century. We've discovered that the symmetries are should be the guiding principle in writing down the theories. In a way, it is simplifying the laws and trying to relate some phenomena that may be completely unrelated by the symmetry transformations. And so that was, I think it takes a little bit off the track, but nevertheless, that's the approach. The difference between in the level of assumptions. Other comments?
Yeah, I will say that it's not only the level, it's maybe more the language used in those assumptions. That scientific assumptions, they use
Right.
higher level of language.
Yeah.
That they use, for example, math and philosophical assumptions. They still use some kind of logic, but religious assumptions, you probably have lower level of language with fewer restrictions.
Well, okay. Well, I don't want to get now. What I completely agree with you is language, and this is a compression of information required to describe the world. And that's again, like the more you can compress, the more you can come up with the more compact language to describe it, like field theories, or the better the theory is considered. So in this case, it is again a lower level description. It is again Occam's razor principle all the way, coming up with the language that can compress very, very, very different phenomena together. In fact, relate them. So I think we're not disagreeing here, but it is true that sometimes you may like let's say logic. Like logic is a good example because it is mathematics, and it is heavily used in some philosophical constructions. But you cannot base everything just on logic. There is many more other effective ways of compressing information that comes with the mathematics, with different branches of mathematics. I'm not again arguing against philosophical or religious or scientific approaches. I'm just trying to identify what are the key differences.
So basically you're saying it's the simpler is the better.
No, I didn't say that. No.
Not necessarily.
No, I said,
okay.
This is the difference.
Okay.
The difference. So and because there is no well-defined definition of complexity, really comparing together what is simpler or what's not may be actually very subjective. So
yeah, you're right. You're right.
And so I'm not trying to argue against one or another. However, in context of the neural network theory, you can try to do that. So you can try to say, okay, what is the smallest neural network? There's fewer nodes that will be able to predict the results of more and more experiments. And then you can really be in the game of comparing the complexity of a neural network where mathematics, general relativity, and the quantum mechanics was used versus another neural network where this mathematics was not used, but certain phenomena were just postulated, like it has to be, right? So and you would you can compare the two neural networks and say, okay, which one is smaller, which one is more compact, so that's but I'm not saying that one is. In fact, I'd like to also point out, since we're on this topic, the disadvantage of using a purely scientific method, which is very, very compact. Now, once you have a good compression, very good compression, changing the protocol, the algorithm of compression is very hard. Any little bit modifications to your theory, you tune a little bit your constant to the left and right, and everything breaks down. So you cannot really do that. So yes, it may be a compact way of acquiring information, of describing the world around you, but this description may be too static, not enough dynamical to adjust for new data, for new experiments. And then you would say, well, then you should be more philosophical. You should extend your assumption. You should be able to extend your toolboxes. And then, strictly speaking, it looks like as you are being less and less scientific because you are allowing to change your assumptions, you are allowing to bring in new mathematical tools. But it is actually a right strategy if science or a theory is stuck in the local minima, if it is not advancing enough our knowledge. And so I'm not arguing here for purely scientific method where the complexity is the smallest versus it's a completely religious approach or philosophical approach where there's not much constraint. I'm arguing for all the spectrum in between, and in fact in some cases you want to move further away from the mainstream science and try to entertain other ideas. So that's kind of
so that reminds me of what's happening in the study of consciousness, because that's a huge philosophical program, I guess, or whatever you want to, and it's less about the brain, the scientific, description of the brain.
well, it shouldn't be.
It shouldn't be. Yeah,
shouldn't be. So any phenomena that you want to include in your description of the world, and if your current standard model doesn't include it, you should be able to extend it to extend it. Now, extend it, figure out what are the missing assumptions, what are the missing tools, mathematical tools, and then try to, once you identify what they are, trying to again move in the direction of the Occam razor and now bring it back to the scientific. But this motion of adding entropy, so to say, to the scientific frameworks is actually very, very productive. That's what neural networks do when they undergo learning. If a neural network stuck in the local minima and it kind of got the best it can from whatever data it learned before, the only way for it to get unstuck is to increase its kind of learning rate, temperature, to try to find minima that include more phenomena, more of the environmental data that it tries to predict. Okay, so now it brings me, if you mind, to the third question, what I think is relevant, because if you are allowing to, if you're stuck with some kind of frameworks, then there are always red lines, because framework is finite. It kind of contains a finite number of things your current model predict or explain. It can be scientific, purely scientific model, purely religious model, purely philosophical models. And then there are red lines. There's certain things you say, well, I'm not going to be explaining. It is beyond the scope of my model. And it is not unique to religious views, right? So it's those red lines, don't look there, don't try to explain that. The same happens in science, right? So physicists would tell you, well, there is a red line. We are not going to explain the emergence of life. We just, it's beyond to what we
leave it on. Yeah,
it's a red line. Or
right.
Religious people say, well, there are certain questions science shouldn't be answering. There is a red line. So I'm actually against all red lines. I think it's counterproductive in both cases. You should be able to answer all possible questions, and you should be able should try to extend your current framework to answer those questions. Now, and by doing that, only by doing that, you can adjust your framework and make it general enough, rich enough to explain more and more of the world. We've been doing it all the time, but somehow we easily get stuck in the local minima and forget that doubting is what makes science great, right? Not just believing somebody
exactly,
right, but doubting. I mean, express doubts about certain things. And here I see very much a similarity between all of the approaches, where people would just get hung up on one set of ideas and not trying to investigate it further. Any thoughts on that? Red lines.
I've never heard about the red line connected with explaining the origin of life. I think scientists always try to explain the origin of life.
Okay, do you know a single explanation of the origin of life that's coming from, well, I do know some that failed to explain it, yeah. So if you use purely entropic ways to explain it, you cannot explain it, and that's your red line. So you don't think it's a red line if people say this is beyond the scope of the current theory? I think it's a red line. Okay, however,
I'm not following you on life. Are we talking about where did it come from, or what? I'm kind of
just
lost.
one of the phenomena that we observe around us, which is in
Yes.
conflict with everything we know about physics, is the appearance of the observers of organisms of life.
Right. Thank you, Einstein.
Right. So the normal approach to be that there is something wrong in my theory, and I should adjust it so that such phenomena can appear. The standard approach is that, well, it's just a very complex phenomena and we cannot explain it currently, so let's put it under the rug. So putting under the rug the problems that you see around you is drawing the red lines. Now, all theories in physics have their areas of applicability, right? So you cannot use, for example, general relativity when the energies are too high, and the core of inside the black holes. General relativity doesn't apply there. You have singularities. Those red lines are everywhere. Okay, so the ability for us to push beyond those red lines is what drives the progress. We are saying, well, no, we have to understand what happens inside of a black hole. We have to understand what the origin. We have to understand how to resolve the measurement problem in quantum mechanics. So, like, pushing all those red lines is very important. Very few people do that. That's kind of my. Most scientists do not work on the red line where you can push the logic, the boundaries of the theory further, but they work inside of the boundaries, and that's kind of counterproductive. But I do agree that there is a lot more red lines that might be drawn by the less scientific people, right? So scientists at least understand that they're red lines and they're trying to do something to push them. Some red lines we can overcome, others are just there. But
so do we have red lines in the cosmic web?
Well, the cosmic, of course, we don't know what the dark matter is, right? So red line is there is cosmic web. I know that you need dark matter for it, otherwise it makes no sense. Okay,
right.
So you have to modify one or another. Either standard model, you have to include dark matter particles, or you have to multiply gravity somehow. And so saying that, well, we have the cosmic web and that's it, and that's like putting all the problems under the rug.
Yeah.
The existing framework tells us that there's something missing, either in general relativity or in the standard model. Yeah.
And what is the cosmic web?
Well, the cosmic web is what happens with the matter in the universe as universe expands. So matter tries to collapse from galaxies and stuff, and those galaxies form clusters of galaxies. And if you look at this structure from very, very far away, if you zoom out, then it starts looking like the nodes of overdense regions connected by the filaments or strings of so it looks like a web. It looks like a network now, and many people had identified that network actually looks pretty similar to a biological neural network. It's biological, it's like just by statistics, by the way it looks. And then the question arises: do they look the same just because there is some fundamental dynamics that can be derived for both systems that is the same? And for example, maybe there is a learning dynamics that drives both systems, but on different scales. And then you can try to identify it. But then, like, for example, it's a good example, because then if we want to bring in learning dynamics and explain both phenomena through that would definitely lead to modification of general relativity. Okay, so general relativity would just be an emergent phenomena that is correct in one case, in one of the limits. And that's a very difficult interesting problem to do. Okay, so let me move on to the fourth questions. Okay, so now I want to just summarize. So what is I will tell you what I think the difference between those three approaches are: religious, philosophical, and scientific. And then you will just tell me if you agree, disagree, or maybe you want to. So I think there are three things that you can say. Well, first about red lines, because we just finished talking about that. So I think for the religious approach, you just absolutely must to put too many red lines of things you cannot explain. You can just keep placing them. Otherwise, and then the model becomes more and more complex. So now with philosophy, there are fewer red lines. You can change it as you go. You can change your assumptions as you go, and that gives it a little bit more fluidity. But at the same, there is still some of them. Now, in the science, we have the fewest of red lines possible. Okay, what it seems like. But then there is a bunch of phenomena. Well, it depends how you look at it. But there is a bunch of really phenomena starting from the psychological level and above that have been completely non-investigated. Like, and biology is, I would argue that even in biology, there's a lot of things that were not properly modeled. And then but by the counting of how much it can model, I think science would be here a winner, because it just has much fewer red lines. But again, this doesn't mean that it doesn't have them at all. They're still there, and they're still a significant fraction of that. Now, this is the first criteria. Now, the second criteria is level of compression, or the level in which the theory is written, or the languages Artyom would say. So the lowest level is for the science. Now, somewhat higher level is philosophy. You already allow some kind of rational, logical thinking about this. And then in the highest level, you pay more attention to really large emergent phenomena without trying to explain where or how they came from. And then there's more compact way of defining things would be on the lowest level through science, through compact way. Just one page of the standard model explains a lot. And then for the religious, you would have to include everything. Okay, and the third one, so the first red lines, then the level of the description, and the third one, experiments. We haven't talked much about experiments, but that's where verification of your ideas comes, right? And with a theoretical approach, you base with a scientific approach, you base everything on the experiment. If you write something new, if you modify your theory, you only do that if you want to explain some new phenomena, some new experiments. And so it's heavily based on experimental verification of your models. Now, in philosophy, it is somewhat attached from the experiments, but precise experiments as we mean them, meaning experiments where you collect data, construct probability distributions, make predictions. But there is some experiments that you do by observing the world around you, right? It's still an experiment. May not be a precise experiment where you write down the formulas, but still is. And my claim is that as you go from science to religion, the fewer and fewer your model of the universe is based on fewer and fewer actual verifiable experiments.
In other words, you have less verifiable experiments as you progress towards religion as a example. Is that what you're saying?
That's right. That's kind of the statement.
Yeah.
And again, this is because of the different framework. And
that makes sense.
That you should still move in that direction. So, I mean, maybe I wasn't clear, but I'll repeat it again. Going in the direction of forgetting your experiments and trying to postulate things that lie beyond what you can currently measure is a very, very useful way of developing theories. Nobody had ever seen gluons. Nobody had ever seen Higgs particles directly, but we saw them indirectly. We postulated their existence. We've done some calculations, and then that led us to the to a better model of the universe. And so doing that, postulating things that are not directly verifiable is a very, very useful approach to modeling the universe. That's the kind.
Huh. Never thought of that. That's good.
All right. So let's move to the question number 5. Are we on time? So yeah, we should. We only have 1 hour for the meeting. So let's. So now I move to the very interesting topic, because I heard this from many different people. Sometimes people say, why do we need to create model of the universe on which everybody agrees? Why not me as an agent, as an observer, can create my own model of the universe, where I will be basing it on only experiments that I can myself perform. I don't care about others verifying my experiments, right? If I have some type of data that I receive that others don't receive, it's their problem. I can still use my data. Maybe I have some, visions. Maybe I have use telepathy. I don't know what, but if it is my own model, doesn't it make sense for me to just not pay much attention to what others say and just use my own data to construct my own model of the universe, which is better? And I think absolutely yes. It's some kind of a single person model of the universe. I think this is the way it should be done. And I think this is what the neural network theory says we're doing one way or another, consciously or subconsciously. But still, within your own model, within your own experiments that only you can perform and verify, you should still decide, do you want to use purely scientific method? Or do you want to base it, which means including a very low level logic and constructions, or do you want to do it on a very high level? It's your decision. And I think that the optimum is in the middle. Yes, you should, try as much as you can in terms of, formal, purely scientific description, but then you have to remove those boundaries and try to basically include as much of the less confirmed assumptions about the universe, even if there's nobody else that can check it. Just you. I think this is a great way to do it. So it will be like a personal agent's view of the universe. I see no problems with that. I think this is what we do it one way or another. After all, we all are very different. We all have different trainings. We all have perceived universe differently, and having our own models of the universe is the way to go. But of course, learning what other people think about their models is just a useful algorithms for us. Any thoughts on that? And this is Katya, by the way, this is a question. It's completely inspired by what you told me, and not just you, other people as well. Because people may have their own experiences and they still want to try to construct their own models of the universe, and doing that without necessarily checking with everybody else that this such and such phenomena other people experience is of no use. You don't need that to build your own model.
Okay. There were actually 2 questions. The first question, does it make sense to construct your own theory? And the second question was, should you pay attention to others' theory?
Right. So
you answered
the second
yes,
question.
just once.
Yeah. Paying attention to others, it's a very beneficial algorithm, right? Others, meaning many people, had asked similar questions, and they have tried to do exactly this modeling. To paying attention, so the model they come up with is absolutely a must, and that's why learning as many of the other theories, explanation of different phenomena is the way to go. But given that you should not limit yourself, that's it. I mean, I can never think about anything which is no other person ever discussed, just because I will never be able to convince the other person that this is the right theory. Who cares? I mean, if you convince yourself, you learn all of the other theories, and then you can yourself have some other phenomena that nobody else has, and you're trying to seize, and then you're trying to explain it, go for it, do for it. But then I still use, scientific methods and such.
Okay,
So yeah,
so you answer yes for both questions.
yeah, I think so.
Yeah,
I think so.
all right, and like the theories constructed by others, they can be a part of your theory. So in
right,
your
because-
theory, you integrate someone else's theory.
Right. So I think it's like you're trying to model the universe. You look around at other agents like you. Your first model of those agents, they're just like you, right? And that's a pretty good model. They function like you, but they're not. So the first assumption, they're like you, so you collect information about all of them. They agreed on some series, so maybe it's not such a useless theory. But then you say, well, actually, we're all different, right? So it's okay for me to have a slightly different model of the universe. Like, for example, in my model of the universe, there will be some psychological phenomena, déjà vu, that I personally experience. I have déjà vu. The standard physics wouldn't explain it. The standard science wouldn't explain it. Okay, well, I take the standard science and I say, well, now I have to include in it déjà vu because I've experienced it. I may not be able to include it on a very low level, starting from the variational principle, but I'll still try. And the lower level explanation of the déjà vu phenomena I have, the better it is. And so that should be the tendency.
But what do you mean by standard science?
There's the physics of the
Only
standard
physics,
model.
right?
Yeah.
Because
okay, using standard scientific methods where you can not in the descriptive, like I just described to you what happened, but explain the theories that have explanatory file, explaining why this and that happened. I had pretty clear, in my experience, déjà vu, visions, right? So it was not like blurry. So for me, it is a phenomena that I want to pay attention to because I've experienced. Others haven't had it. So for them, there is no motivation to look at that further. And I think it is completely okay. Once if you like, and by the way, this neural network theory is sufficiently simple, but I think it can be used to model, even for yourself, even if you cannot convince others, to model such phenomena, psychological phenomena, such as the déjà vu or other phenomena that people had experienced.
There is a
I think
there is a model of déjà vu. And there were experiments devoted to deliberately creating déjà vu people, and they were successful.
They were not successful?
They were successful.
Okay, well, there you go. Right. So then I would pay attention to this more. And because I personally had it. So my claim here, it's okay to have your own theory slightly different from the general fit once you have a common framework in which you can describe it. Okay, so I think that's essential, and that's what this neural network theory brings to the table. Now it's sufficiently simple. You can take your own phenomena, take your own religious experiences, your own religion or model of the universe, and formulate it in this common language. And then not only you will make your model better, you'll be able to communicate to others your model, and maybe somebody else will find exactly model you're experiencing. Somebody else will find it, and maybe there's just not just you, but maybe there's a group of people. This group of people experiences this type of psychological phenomena. The other group experiences some other type of psychological phenomena, and then there wouldn't be one theory for all, one shoe fits all, but there will be like groups of people that have common description of the universe with slight modifications that this framework allows you to do.
But if
I was just going to say that the fact that I'm here today, participating, is a result of like 3 or 4 years ago, when I all of a sudden found something about the cosmic web, and that just turned me on. And then I got a astrophysicist friend of mine to join in, and we ended up doing a paper. I mean,
that's right. That's exactly how it should be done.
That's the way it should be done, I think. And
it's
what
okay.
Go ahead.
Yeah, it's okay if you are the only one or a small group of people But what is important is to be able to write those theories within a common framework, a common language.
Exactly. Yeah.
So there is a very good language that physicists developed, which is called language of field theories, and then the different phenomena can be described as, it's very broad language. Neural network theory brings in another framework that perhaps is even more general, that allows you to write even more things you're using. Okay, so let's move on. Now I want to quickly go through this sixth question that I think sometimes helps, sometimes harms the development of theories, whether theories of individual agents or theories in general, or models of the universe. And it applies to all three, to scientific models of the universe, religious or philosophical. The influencers, the people who influence opinions of others, right? You can have a very well-known scientist who firmly believes in his own model of the universe, and maybe most of it or big part of it was never verified experimentally, but he still believes it, and he is so influential that people start believing what he says, or she, without verifying, without checking the calculations, without checking the conclusions that were it. So this is very dangerous. This is very dangerous in science. This is very dangerous in religion. This is dangerous in philosophy. If you do not have ability to verify, like in principle, ability to verify what the person says, then you should not just believe it and trust it. Of course, you can never verify all the calculations that were done by science. There's just too many. You cannot reproduce yourself all of the experiments were done. So some of it you have to believe that's true, right? So I've never done simulations of the cosmic web myself. Okay, I've seen the results of people who did this, and so I can have some indirect check, but not directly.
Yeah.
But then there'll be maybe influencers who influence my opinion by just telling me, well, this is the way it should be done and no other way. That's very dangerous. If I have no direct way of verifying it, even in principle, that's even more dangerous. And that's the side of things that we should be trying to avoid, whether in religion, in science, in philosophy, having people whose opinion are taken without doubting it.
Exactly.
And without us being able to check and verify it. This is the most dangerous thing that can happen in any of them all. You absolutely have to believe something because you cannot do all calculations, but you should also have all the tools available for you to verify it.
So what's your final answer? Sometimes positive, sometimes negative?
Right, so it's a higher order interactions, agent to the real world interaction, kind of something that Artem already asked me. I'm an agent. There is another agent who has also model in the universe. Should I just blindly take his model and adapt it to myself? Or should I be able also to indirectly verify the prediction of that other agent? So like three-body interaction, agent, universe, right? And the question is, if there is no way for me to verify it directly, I shouldn't trust it. If there is a way for me verify it directly, then even in principle, then there is a more trust to it. So it's a type of the three-body interactions, but a very special type, and so you have to be careful about that. All right, so let's move on. We are probably already. No, we still have time. So the seventh question that I have: what is the role of filtering? So we already discussed filtering before. It's useful for the observer to filter information. But what is the irrelevant information? But what is the role of filtering relevant information? So some information is relevant. You've already based your model of the universe using this information, and then all of a sudden you receive information that is in conflict with your own theory.
Yeah.
What people tend to do is to filter it, just throw it aside. So cherry picking. Let me not look at the data that puts my model of the universe makes it wrong, my own model in the universe. So it's a kind of a tendency of agents to do that. Very bad tendency, right? So what you want to do, you want to take any information can come in and try to include it in your model. If you filter the relevant information, you will end up with in the delusional model of the universe, which is not real, which has nothing to do with reality, because you just filter out all of the information that conflicts with your view of the universe. Very, very dangerous thing. And I think it is something that scientists often do. I don't know, like to get your publication, paper published, to get some results obtained. And it is a very dangerous thing. The scientists should never do that. So presumably honest scientists wouldn't do that, but other people as well. So with other approaches to science, you should be very careful about not filtering information. I'll give you another example we discussed the other day. A gambler who keeps coming to play, for the money, because he filters information about when he loses the money and only remembers when he won the money, right? It's a horrible approach, algorithm, right? When you just remember that you won the money and then erase from your memory when you lost the money, then you will keep coming to gamble, and at the end you will just lose all your money, right? So don't want to do that. So filtering of relevant information is a bug in your system that somehow needs to be resolved. Yes, go ahead, Mel.
I think this happened with the cosmic web. In other words, we started seeing evidence of a network in the universe, but plenty of scientists didn't jump on the bandwagon at that point in time, and so there was many people that were just who had seen this and were kind of left in the lurch until mainstream astrophysics started to go, oh my God, this is really real.
Yeah,
don't you think?
This is a problem, Merrill, with science currently, where anything that is against your current model of beliefs being disregarded. You don't have to go to the cosmic web to discuss the problem. There is a problem of the second law of thermodynamics. Okay, people know that all of the physics predicts the second law of thermodynamics, and yet here we are, observers of a very low entropy state, and that is a real problem that you can face or put it under the rug. Putting under the rug is filtering of information. Another one is the measurement problem in quantum mechanics. You can either face this problem, try to solve it, or you can put it under the rug. So it's very similar to the red lines I was talking about, but really it's more of not putting red lines on the phenomena you're not going to model, but to how you model phenomena. Just don't give me information that contradicts my theory. I don't want to hear that. So that's very counterproductive. It leads to things like overfitting in the neural network language. You're just not learning all of the incoming data, but only a very small subset of data. You become very good in predicting that subset of data, and basically the other relevant information is not modeled by you at all. So that's a very dangerous approach. Other thoughts?
Yeah, I have some thoughts. Like I have some statements. Like first statement: your brain cannot process all the information. Do you agree?
Well, that's why I started. Sorry, let me just repeat it. I started that it is necessarily you have to filter some information, and so you decide what is relevant, what is not. Now you decided what information channels are relevant. You concentrate on them, and then you receive data which are in conflict with your model, and you filter this. So it's not filtering the irrelevant information for whatever modeling you're trying to get, but filtering the already open channels, filtering the relevant information. It's like in the machine learning, you have a large data set, and then you just found some inconsistent data and you throw it away. That is dangerous.
Wait. So relevant by relevant information, you mean?
So first, to model the universe, you have to decide here are the channels from where I will try to model my system. So that there's inflow of information. Like I look at the photons, right? We are not looking at the neutrinos. We filter them out. They are not affecting, presumably. Maybe I'm wrong, but that's the model, right? They're not interacting much with us, but we are taking photons. We are taking sounds as incoming signals. But certain frequencies we filter, right, of light. We just decide not to use it. And that is irrelevant for what I as an observer decided to do. But now let's imagine that every time you see a lightning that you cannot explain, you just close your eyes and say, well, I didn't see anything. Okay. And then you end up with a model of the universe where there are no lightnings, right? And so you just remove this information from your data set. You no longer need to explain it because you are not paying attention to this. And that's dangerous.
Okay, you say you are talking about that as about some bad thing, but let's come from the different approach. Why do you need the real model of the universe?
Why do you need the model of the universe?
The real model of the universe, like
No, you never get the real model. Okay, that's something we already kind of discussed with Katya. But yes, there's no truth. There's no true model of the universe. There's no real model of the universe. It's only the model, the best model that you can get. By paying attention to certain degrees of freedom, by certain information that comes to you. Using that, you can construct the best model that you can. And different organisms actually pay attention to different frequencies, and that's completely okay.
Wait, how do you define the quality of the model?
By the loss function, right? So in the biological sense, it would be like log of the fitness.
And what exact loss function do you use?
Okay, so Katya doesn't allow me to answer a question that we already answered before, but the fundamental loss function is as we think is basically trying to understand, model the environment. So any subsystems tries to model the environment, and that is
But
ultimate
what if the loss function is completely different? For example, like your loss function is programmed by your biological needs. And
yeah, so emergent loss function. Okay, there may be different models. Okay, now the emergent loss function for different organs may be different, but the fundamental loss function for all the fundamental neurons must be the same in this model. Okay, now you're saying there may be other models where there are two different types of neurons. They have different types of loss function, but that is different. I think we are a bit off the track here, because we are now talking what is the right thing to do for the agent who is trying to construct a high-level model of the universe. It's at the level of humans, and it is not on any level. It is not advantageous to you to filter the relevant information, the information that you try to receive and process. You just decide, I'm going to throw it away. It's in conflict with my.
No, well, and I may try to disagree. I will try to disagree with you here.
Sure.
What if the processing of this relevant information has a cost, and that cost is too great, and that's why, like, you or your brain decides not to process this information?
If you do it unbiasedly, it's the right thing to do. Again, we also discussed it, but it is the right thing to do because you only have a finite computational resources. You can only process so much information, so you absolutely have to coarse grain over it, remove some information, compress it. Now, if you do it unbiasedly, that's great. If it's a biased one because it only disagrees with your model, then it's a dangerous thing to do. So that's it's like throwing away some samples in your data set that give you the large loss function. You will artificially make your loss function smaller, but not because your model is better, but because you're just throwing away the outliers, and that's not good. Okay, Artem, we can talk about this later. This is an interesting topic, but we are running out of time, and I need to read three more questions. So, what is the role of dynamical adjustment of assumptions? So, remember we talked about assumptions, kind of the things that are irrational, but it would be nice if you could adjust them dynamically, not just say, well, this is my assumption and I'm going to change it. And I think this is another example of having ability to change those assumptions dynamically. Gives you more freedom to finding the right model. And if you have some textbook written by, I don't know, founders of quantum mechanics, and you just take it as a ground truth that never to be rewritten or adjusted, that's dangerous. If you allow yourself to change it, then it is the right approach. In fact, the reason why Einstein came with his general relativity, because he said the assumption that Newton made should be adjusted. He said what the adjustment should be. So this is, again, a clever algorithm that needs to be used. Not that you should make those assumptions arbitrary, but you should make them dynamical. Okay, and the follow-up on this, what is the appropriate time scale for adjusting parameters? I don't know the answer to that question, actually, because it seems like the theories, the assumptions of theories change on the time scales of about 100 years. So that's kind of usual time scale for theories in physics, at least, to change. Whether 100 years is the right time scale, or it should be smaller. And so, like Newtonian mechanics, then 200 later, quantum mechanics, then general relativity. The same. There was like classical mechanics before, then quantum mechanics. And so, roughly speaking, this is the time scale. Very, very slowly changing assumptions. Should it be faster? Should be changing like, I don't know, every year? Maybe that's too often. But what the right time scale? I'm not sure. But anyways, I would be advertising that if your loss function doesn't decay much, if you haven't made any significant modification to your theories and haven't made significant any new predictions in the last 40 years, which is what we have in theoretical physics. In the last 40 years, we haven't made any new theoretical predictions that were later verified experimentally. Cosmic inflation was the last one. Gravitational waves was listed to verified gravitational waves, but they were discovered way before, where they were theoretically predicted way before. But for the last 40 years, there's nothing new in, and so presumably it's about time to change.
What about your paper on the cosmic web?
Well, again, I'm talking about theoretical assumptions. So if the assumption that the universe on the fundamental level is a neural network, if this assumption is correct, if we can convince ourselves that it leads to right predictions and new phenomena, then this is the type of things that I would say, well, you change the assumptions, underlying assumption of your theory. But at this point, this wasn't made yet, and I'm just saying this is evidence. For 40 years there was nothing, and so it's an evidence that maybe some assumptions should be made. But then coming to the last question, and then we'll just see what people have to say. I think there's really no alternative to the scientific method, but by scientific method, I want to understand a dynamical scientific method. Not a scientific method, not a theory where you just declare your framework and you stay within it, but where you constantly doubt it, constantly change you allow modification of assumption. You have some kind of trainable variables that change it, that describe this change. And if you have that, then I think, and I think that the right time scale is not 100 years. It should be smaller. It should be more like 10 years, where you because every 10 years you have some new mathematical tools that are at your disposal. And that you can try and see, and with that, I think a much more rapid development can make place. And it doesn't matter whether you are talking about using a theory that everybody would agree with, or a theory that a given agent would develop. I'm completely okay with that. Groups of agents developing theories, as long as they stay within this scientific framework. Any other thoughts?
I think scientific method is good for its purpose, but not for absolutely everything.
Okay, can you give an example of, not for everything, for modeling the universe around you? So are there any alternatives to scientific methods if your aim is to model and predict the universe around you?
Okay, but modeling and predicting is the purpose of scientific method, which I was talking about. So there is no good alternative.
There's nothing. So if you can do anything at all, you can of course do anything you like. But if your point is to explain the world around you, to understand the world around you, then there is currently really no alternative to scientific method. But again, I will emphasize that not the scientific method which is static, but a dynamical scientific methods where you allow assumptions to vary on a shorter time scales, when you allow your mathematical framework to vary and change on a shorter time scales. And again, I also will add to this. It is okay to also develop your own personal theories as long as they are following the scientific method, because after all, we're all different. We may have slightly different models of the universe, but if you are using those methods, you are most likely to receive a model of the universe around you that agrees with the experiments and observations the most. Okay, we are past 1 hour. So if there are any final comments, questions, I would love to hear them.
Yeah, I have a lot of questions, but none of them is the final question.
No. So this whole meeting was about the three, which seems to be different approaches: religious approach to understanding the universe, philosophical approach to understanding the universe, and scientific approach. I don't think there's a sharp boundaries, and I think you can borrow from different approaches useful things. But what is, anyways, this neural network theory suggests that having it to be dynamical is much more beneficial than static. There is one equation that describes the universe. Let's just stay with it. There is one book that describes the universe. Just stay with it. It has to be something that is dynamical. It changes as new information arrives in, rather than filtering this new information, include it in your theory and then in your model. And then that would be a better way of modeling the universe around the agents.
Well,
So
I have some comments.
Yes, of course, Katya.
So, well, first, I should say that yes, all that you talked about is useful, and thank you for these efforts to structure. I mean, in the context of what we discussed previously, it is really useful. So, what is still left confusing is first we are using different definitions of what is religion, but I would probably approach from another end. We are saying that scientific approach is the best for modeling the universe. Then what do you are there any other goals? If so, what we mean by modeling universe? If we mean that in the context of the theory, actually this is the only goal, that every agent is this or that way pursuing, then it's one thing. Or there are some other goals. So how do you think of
I think the fundamentally goal is one. Fundamentally, the goal is to understand the universe. Any subsystem is trying to understand what it is surrounded by, understand its environment, learn its environment. But that's fundamental. Now, on the emergent levels, this may appear as different emergent phenomena. For example, pain, right? So you want to minimize pain, but that pain is an algorithm for organisms to know that there is a danger around, and if danger is not addressed properly, the modeling of the universe will be impossible. Okay, so now you may say, okay, well, the model, then a good loss function is to minimize pain. And that's a high level modeling. It's on the lowest level, it is still to understand the universe.
No, I
but there-
think this example is actually it fits this notion that the goal is to model the universe, because you have to have a model of what is pain, and pain is not always how to say the optimal way of treating pain or understanding it can be different in different situations.
Right. No, but well, I was saying, like any higher level psychological phenomena. Pain is one example. I don't know. Love is another example. Happiness is the third example. All those phenomena, they are emergent. They come, and we should have a separate meeting about all of the emergent psychological phenomena.
Well, what about life? What about life in the universe?
Now, life is just the learning dynamics, right? So life is a process of learning, and certain organisms have achieved a more efficient learning algorithms, and so they're more efficient learners, they're more conscious learners, and that's how we distinguish life versus non-life. But I think Katya's question is, let's concentrate on a psychological level, and at a psychological level there may be very different emergent phenomena, and we just described, the love, pain, happiness, but they're just useful way for you to learn the environment. For a subsystem, you learn the environment. This gives you additional useful information for learning the environment. That's all. Now, there's nothing in addition to their fundamental loss function. Everything else is just a useful way of doing this, like useful algorithms.
Where does consciousness fit in?
Yeah. Well, okay. Actually, I should now say that there's now a video on our YouTube channel where it answers all those questions, including consciousness and everything. Frequently asked questions video. So
Okay.
and the consciousness is related to the efficiency of learning. So this is again a mathematical expression you can write down and calculate what it is. But I think
Cool.
Katya
All
has
right.
something else in mind. So let's finish.
Yeah. So I so far I don't see how about the following field. People research, if one researches let's say, I can say internal states, but it's a problematic wording, because it can be understood differently of what is internal, what external.
No. I think it's a very well defined. The state of an agent, internal.
No,
state...
I mean in psychological sense, what we call internal.
Yeah, in psychological sense, we have to define the emergent parameters, right? Not fundamental, but emergent parameters. It's like temperature is an emergent parameter in the physical system. So there's consciousness is another emergent parameter in a large enough system.
Yeah, I agree with you that we should go deeper into this and define what we mean by that.
Right.
But just now I want to use some approximate term to try to explain what I mean. So
consciousness. Let's use consciousness because we already defined it in the videos. It's so there is a different level of consciousness for different organisms, and actually it may also vary with time for a given given organism, a given agent.
I don't know now how this relates to what I'm going to say, because
you wanted to define some kind of internal state.
No, I just started talking of what I try to.
Okay.
Oh, okay.
So
okay, go ahead.
I got you.
Meryl, I think we can hear you talking. Meryl.
Yeah. Okay. No problem.
you can turn off the microphone.
And you're just going out on errands, huh?
I don't think I
Oh,
can.
that's right. Shit.
Yeah.
Okay, go ahead.
So if the goal is to research, investigate the internal states and some psychological states, and if your goal is to investigate it and find some approach to manage that and achieve some kind of preferred states, not by making some changes into in the external so-called external world, but with your own psychological or whatever structures. So and what is this? I mean, and then you were talking about some influencers related to the probably to religious topics.
No, also scientific influencers.
In particular, I mean, in particular. But what is what I call the what I really mean with religion is establishing some states or experiencing some states, and the influences, the good influences in this field, they say exactly this, that you don't have or you shouldn't believe something. You should achieve some experience, get some experience, or live through some experience, and then you should check. You should investigate and make it your own experience.
Okay, so Katya, you're saying you should achieve some internal state. For what? What's the goal of receiving some internal state? What's the goal?
Well, that's a good question. I think that
this is a learning theory, right? Unless we identify the goal, we cannot really within the context of the learning theory.
Think that, yes. I think there can be two. I can attempt to answer in two ways. First,
but Katya, do you agree that this is not a religion in the usual sense as we understand it, but this is more of
the usual? I have checked Wikipedia yesterday, and I have it confirmed that there is no one definition that you.
There isn't. So, but we have to stick with one. We stick with one,
yes, and you suggest to stick with yours because most people use that, but I don't see it in.
Yeah, I think we can have a different word for it. But if the point of religion, of philosophy, of science is to model.
What I suggest is get rid of the word religion because it will cause problems because there are the opposite definitions. And
what's the definition? You're not answering me what's the opposite definition is. You're just saying that there is some experience, some internal state that has to be achieved for some loss function, for something like this. So this is how I interpret it. And I'm saying that if it is in the context of learning theory, whatever state you achieve it for minimization of the loss function. That is, in this case, has to be for you to better understand the environment. It may be the physical environment around you. It may be hidden environment that we discussed. But both of those, whatever you do, it is to learn the environment, to understand the world outside of you.
Two points. First, what about the goal to achieve some preferred states?
That has nothing to do with religion. That has nothing to do with religion. This is a different goal.
It depends on how we define religion.
No. Religion is a model. Religion is saying about by religion you describe what is your model of the universe. This is what religion is. It is a way of describing what the universe is. Let me give you an example. Your model of the universe may be such that there are internal states of you that allow you to receive happiness. That may be your model of the universe. And we can model it using religious method, using philosophical method, but it's a model of the universe. And you're saying that not the goal, but the model, right? And then you can say, well, the model of the universe is to be such that I can receive this state, and this state somehow will lead me to a better learning my environment. Maybe, I don't know, but it is your model of the universe.
Yes, that makes sense. And now, how we can apply mathematics to this?
Well, I'm explaining you. So this is why I said that on the question number, I don't remember 5, it was exactly about this. When you are constructing your own model of the universe, okay, you don't care about anybody else. You just concentrate on your own experiences, on your own experimental data, like you achieve some happiness or what's not, and you're trying to describe all this using the mathematical language of neural networks. So you are, for example, I just gave you an example. Then maybe the experiences that you're talking about are not related for you to interacting with the physical environment, but for you interacting with the hidden environment. Okay, this is for you. This is how you are learning that hidden environment, how you interact with this hidden environment. And if that's the case, great. Then you can write down the model and try to describe it. Try to make a predictions of what you should do so that you come into a state of meditation, and that state of meditation will allow you to increase the bandwidth of interaction with the hidden world. And once you increase that bandwidth, maybe you will be able to receive some knowledge that others of us cannot receive it. Or maybe we also can if we start meditating. But again, all this comes back to the way of you to model the universe. Okay, not just postulating it, but trying to figure out how it works. And then the more you figure out how it works, the more scientific it becomes. So it's again not a religion. The initial statement was a religious statement that you made. I think there is some preferred state in which I should be.
What is what is the difference between philosophy and religion?
Whether you are allowing yourself to change your assumptions, how dynamical they are. If you just started with some assumptions that you read someplace or some influencer told you, and you are no longer changing, you just stick with this.
But then why now you're using the word religion when you in your previous sentence? I don't understand how it is.
Because you use the word religion. I think what you're saying is more philosophical approach, not religious approach. A lot more philosophical.
Yes, because I have different different definition of religion. I don't know.
But we can see, like, we cannot just have one word used in 2 different contexts. That would be very confusing. Okay, I'll give you one way out. How about static religion versus dynamical religion? Do you like that?
I don't know. I think that this using continuing using this word in our dialogue is not productive, because we are missing these senses.
But I always explain what I mean by it. By religion, I mean a fixed set of assumptions that is not dynamical and that not need to be verified experimentally. Whether
to continue this dialogue, I should accept your definition, but I have my own. And
tell me what it is. No, but you're not telling me the definition. You're telling me what you think. You're telling me about state that a goal. Oh, you're telling me about the goal of your religion. You're not telling me what the religion is in general.
And
I want you
to the goal of
give me a definition. Okay, so this is what would be useful. Come up with a definition of religion where they can be your religion, they can be some other religion, and 10 more other religions. That would be a general enough framework. Yeah. So there'll be one definition.
I don't think it's relevant. My religion, some others' religion, it is not relevant to what I mean with religion. With religion, I mean some I don't know, technology or approach.
Answer one question. So you are by the word religion, you mean something else. So something, right? You mean something but the word religion. Can you give me an example of a religion which is not the religion you're talking about, some other religion? I want to have like 10 different religions. One of them is yours, and the other is the others. Can you give me an example of something which is a religion but outside of your view of religion?
I can't.
You cannot. So for you, it's not a definition of religion, but a definition of your own model of the universe. That's what I'm trying to tell you. You're trying to say that my religion is the only correct model of the universe, and this is wrong. This is your model of the universe. It may be the best model ever, And then for this model, you can use purely scientific methods, which are bad. You can use purely religious methods that are not also productive, and anything in between. This is just an approach of modeling universe. And in fact, it looks like in your model of the universe, you pay more attention not to the world outside, to the environment, but to the world inside. You are more interested in modeling the agent itself, which is also the model of the universe. And that's completely fine. And it can be modeled using the neural network theory. And it can be modeled using scientific methods and only postulating. Okay. So in this case, once you come up at the end with your model, you write down all your equations, you will conduct all the experiments, then we can decide where it stands on the spectrum. But before that, we don't know that. So anyways, I think this was a good discussion. And I think this tells me that perhaps one of the next meetings, we should only concentrate on psychological phenomena, okay? We don't have to call it, religious experiences. We don't have to call it meditation. We don't have to call it, déjà vu or whatever. We'll collect all of the psychological experiences, phenomena, and try to see what they mean in the language of neural networks. So just on purely psychological level, not modeling the entire universe. That's hard, but just going inside of the agent, trying to understand what kind of models they have. This will be a complement to today's discussion, where we actually try to see what's the right to model outside. So maybe next time we can model inside and ask
which
questions.
is the brain, which is basically the brain.
Which is basically the brain, but yes, exactly. But this brain, as we argue, can have connection to the physical world. In this video, frequently asked questions, also can have connection to the hidden world. So there are many non-trivial phenomena that may happen inside the brain, which may be very relevant to what people call as religious experiences, or other people can eureka moments, right? So maybe when I figure out something, I have exactly the same experience, right? So I write down equations, I say, well, it works, an aha moment, right? Maybe that's also the very same phenomena you're talking about, but using different language. So we can take all of those phenomena, put them together, and one by one, try to identify what they mean, model them. And if we model them, that's a scientific approach.
I got a good one for that vein. I think it would be interesting to model near-death experiences.
Another one. There we go. Okay, so again, for that we need to collect a lot of data, see what other people, because not all. This comes back to my fifth. I think one of the.
I had one, by the way. That's why I said it.
Yeah. No. It is important that some of those phenomena we do not need all to agree on that it is real. And that's the benefit of this. We just have a framework.
It was real to the observer.
Yeah, unique to the observer. We have an agent, we have a framework, and we'll just take experience, try to learn as much as we can about this, and figure out how is it beneficial for learning. And that would be interesting discussion. But again, I don't think we should mix it with what the words of religion or philosophy or sciences. But okay,
no way.
Any final comments before I close the session?
This was good. I appreciate it. Thank you.
Thank you. That was very interesting, very pro. And I'll see you guys next week. Bye-bye.
Thanks.
Perfect.
Bye-bye.
Thanks. Bye.